We are at 127, and I wanted to do the SQL injection project where a student pointed out to me part of this was broken, and I fixed it just a day or two ago. So first, there's these sections, section 1, 2, and 3. Each section refers to a different database, and you have challenges to solve. So I first reset the server, and now I can demonstrate what SQL is. Now the point here is you have already done, in previous class we talked about command injection, where you inject Linux commands like cat and grep and ls. And that's easy. In SQL injection though, you're talking to a database server and you can inject commands, but you have to inject SQL commands. It's just a different language, so you have to learn the basics of the language SQL in order to use SQL injection. And here's what it does. A database stores data in databases and in tables, and you can see what databases are available. If you have the ability to execute raw SQL commands, you can just hit show databases and it will show you what databases exist. And there's two databases here. There's one called widgets, which is the one that contains company data, and there's one automatically generated by the MySQL software called information schema. And the fact that the structured query language servers always create these automatically generated tables is what makes this possible, because there are certain objects that are always there and they always have the same name. So you know what to look for. Now, so if you have the ability to execute queries on the database, which is what the database administrator can do, you can use it to control the database. So here's a few commands to learn the basics of this. You can see the databases and you can see the tables. And when you look at the tables, it automatically assumes you're in the current database, which is widgets, and the only table in there is employees. There's also stuff in the other database, and we'll see them in a minute. All right, so now you can also select just things like one. Now we did shows object, select, looks inside the tables to find things, but you can also just select a constant like 1, and then the answer is 1. So you can just echo back a word or a number if you want to. Now you can also select a string like peanut. Doesn't have to be a number. Oh, didn't take it, my copy didn't work. All right, you can select peanut, and now the answer is peanut. So you can use numbers or strings, and you can concatenate things together with the concat function. So this will concatenate peanut and butter. So the result will be peanut butter. All right, that'll be important to us later. You can also pick pieces of a string out with the substring function. So this will take the string peanut and it will pick out 2 characters starting at character 2. So that's EA. 1, 2, these are the 2 characters starting at the second character. And that will be important later too. All right, now we can get data from tables. We saw that there was a table called employees back here. And like I say, you can get anything you want in SQL, but you have to tell it what you want by name. So you have to know the names of things. Now here we found that there's a table in the widgets database called employees. So if you want the data from employees, you can do this. Give me all the data from employees. The star is a wildcard. All right, that gives me everything. And so the employees have ID numbers, names, and social security numbers, and there they are. There's a variety of employees in there. All right. So if I go back, I can select just one column. Now notice here, there was ID, name, and SSN. Those are the columns. The table is employees. And these are what you call the rows, these different items. So I can select the ID column, and then I'll get just that column, just the ID numbers. All right. Then I can select ID, and I can also select a constant, like 2 here, and then I'll get 2 columns of results, the first one being ID and the next one being 2. And I can just get a static value, so you can mix static values and data that came from the tables. What's more reasonable, though, would be to select name, comma, ID. That would make more sense. Then I'd get names and IDs for each person in there. All right, and now, I can also specify what I want. I can put this where clause in to get the data about just a certain number of records. So I'm only going to get records where ID equals 1, And there's only one record like that. And this is what's going on when you raid your Gmail or go to Facebook and look at your page. There's a database with everybody's information, and it checks to get just the information for you and show you your email, your Facebook wall, out of some huge data. You're doing a query on the database to get the data for just one user. So now, this is one more complicated version that combines it all. It's going to select the concatenation of name and ID. Let's do it in steps. If I concatenate name and ID here for this one, then instead of getting name and ID on separate rows, I'll now get a mixture. So Bill Gates 1, the name followed by the ID on one line. So that's the first thing. Now, I can get from employees, that's good. And here's the where clause is going to be more complicated. Now here I have where ID equals 1, but if I do this, or cat equals dog, I can have a compound logical condition here. ID equals 1 or cat equals dog. Now the ID will be 1 for the first record. Cat is never dog, so I'm just going to have the same result. I only get Bill Gates 1. All right? But if I now put in this, or 2 equals 2, now I've got a condition that is always true. This is true for one record. This is never true. This is always true. Since I used or, if any one of these is true, the answer is true. So this is always true. So now I get the whole database, all the records. So that's a thing to know. If you can combine a second condition with an or that's true, you'll get all the data. Now you can insert data in here, and you can see somebody's been doing it. That's why there's several copies of the Kevin data in there. And you can select. Now we're doing all this looking at the employees table. But like I say, if you were hacking into somebody's server, you would not know the name of the main database or the name of the tables in that database to start with. So you would have to find them by starting from the built-in tables. So the information schema is always created, and it has tables. So if I do this, I'll get a list of all the tables. And as you can see, there are a lot of tables. All these capitalized tables are the ones that are automatically created in there. And way down at the bottom might be the tables in widgets, but I guess not. We're only looking at this one. So many, many tables are created automatically by the system. Here you can get all the table names. That had tables and some other information. Here I'm going to get just the table names from information schema tables. There, and there's all the table names in a database. And so those are all those ones. And down here's the one for widgets. All the tables are there, but all these are automatically created tables that are used internally by MySQL. This is the one that contains company data. So now I can find columns. So if I go down here, I'll get all the column names from information schema columns, and I can only copy this thing without it filing up. All right. All right. Now I get all the columns in the database, and there's a lot of them, all these capitalized ones, and way down at the bottom are the columns in lowercase created for the company. So ID, name, and SSN are in the employees table, but this is why now I can see the columns. So I was able to find out the names of the columns and the names of the tables in the database without knowing it to start with. From this one, I got a list of all the tables, and I could see which one is new, and I could use Gus. So that's how you find out. So now that I figured out that there's a table named employees, let me just repeat this process, hopefully to make it clear. I select the table name of employees. Okay. Now, if I look at the end, I see there is a table named employees. So if I didn't know that, I could find out this way. Now that I know there's a table named employees, I could use this to find the columns in that table. Select column name from columns where table name equals employees. And now I get ID, name, and SSN. This is how you hack into a server. First, you have to find the name of the table you want and the name of the columns in that table, and then you can get the data out of the table. So this is just a practice of basic SQL commands, and there's a couple of flags you can find with those commands using one of those queries, and then we can do SQL injection. Someone says, how is this prevented? It's prevented by writing parameterized queries in your SQL language. However, what we just did is not prevented at all. Your database administrator always has this right, and you would never let a user have access to this pane. You would only let the administrator do this. So what we've done so far is just basic SQL as done by a database administrator who's authorized. Now, this is the issue for security is you would never let a user execute an arbitrary query on the database. What you let a user do is something like this. They can search for a name. So if they search for, say, Bill Gates, then they will find Bill Gates. So this is what you might let a user do, just search through a database. But it turns out that if you're not careful, you can give them the ability to execute commands as if they were the database administrator by accident. So if you use Tip O'Neill, now what happened here, this is the query that was executed. The developer put in all this. Select name from employees where name equals quote. Then the user put in this data, and then there's a quote there. So what you did here, the mistake was you took data that came from the user and included it in a line which was then parsed to try to match the apostrophes. So if I put an apostrophe in a name, it interprets this as the name, and then after that it expects a command. Now since Neil is not a valid command, that's an error in my syntax. It was fine up to here, but Neil is not a SQL command. So I've now created a denial of service attack. I can now stop the query from running by putting in invalid data. I have to do something more careful, and that's what this one is. If you put in this, well, first let's look for Sam, and there is no Sam, so you get no results, okay? But if I put in this one here, Sam or 1 equals 1 pound, then look what happens. It turns into where name equals Sam or 1 equals 1, and the pound is a comment symbol, so it gets rid of that extra apostrophe. So now the condition is name equals Sam or 1 equals 1. This is never true. This is always true, so I get all the data. This is SQL injection. I was able to inject, all I did was put in this name, and I was able to inject a command. The or, 1 equals 1, is code that only the developer should be put in there. So now I made this code that the developer wrote do something different than what the developer intended by adding extra code. This is command injection in the language SQL. And to prevent it, you do not use this kind of way to handle data on the server. You use a parameterized query where you define a data object here, which is connected to the data that came from the user, and not put in a line of text that's parsed, trying to match apostrophes. That's the right way to do it. That's called parameterized queries. But this is the old-fashioned way. A lot of SQL databases are set up where they take user data and put it in a line of text that is then parsed, and that's what causes command injection. So you can do it this way with the comment signal. You can also do it this way where you do not need the comment symbol. So I put in a name of this, and that turns into Sam or A equals A, and this apostrophe at the end is used, and this apostrophe at the start is used. So now even without a comment signal, I've contained a condition that is always true, and I get all the data. Now, all right. Now here's how you add a whole select command. If you do this one, now you can do a union. So you have one select query here, select name or name equals Sam, there's going to be no results. Then you have a union, which means perform a second select query and add it to it, and this one will select 1. So I get a 1. But now this is the name I put in, so now I am able to inject a new select command. So what I've done here is I have taken this box where I can only put in a name, and I've turned it into this box where I can put in an arbitrary select query. So if I wanted to do one of these things, like for example, select table name from information schema tables, I can do that now here. I have to get this thing to stop doing crazy things to me. All right, there. I can do any select I want here, including that one. And now I get all the table names. If I go to the bottom, I see there's an employees table and a passwords table. So this is, by using this construction, I'm able to do it. However, if I were to try to select 2 names, table name, comma 1, so I get 2 columns, then I'm going to have a problem. You have a different number of columns. The developer wrote this select query, and the developer only selected one field, name. So if I try to select two fields, I cannot add two columns to one column. So if I want to get more data here, I have to concatenate it back into one field, and you can do that with concat. So if you do want to get more fields than the developer did, you use concat to stick these two together. And now it will work. You get all the table names with a 1 at the end. So that's how union works. And by doing this union, you now gain the ability to do what only a database administrator should be able to do, inject arbitrary commands. And there's a bunch of flags defined here using that. And the professionals, by the way, almost never do it by hand this way. They use SQL map. It's a hacking tool. You'll find it in Kali. If you're taking the pen testing course like 123, you might want to use SQL map to attack this. It's optional. But I would skip that if you're not taking the pen testing course. That's not that interesting for the Exploit Development course. But the last part that's a lot of fun is blind SQL. And this is where you play the game 20 questions. When I was a kid, we would play this game. You can ask a question, but you get a yes or no answer. And you're thinking of something, and you try to narrow down an object just based on yes or no answers. So I reset the server. So here's another one where I can just search for a name. So here I got Bill Gates. And so when I do that, the developer has put in this, select name from employees where name equals, and then you have Bill Gates. So it found Bill Gates, okay? Now, all right, if I put in X, there is nobody named X, so I get no results, okay? If I put in X apostrophe or A equals A, this is similar to the one I did before. Now I'm going to get a condition here where name equals X, which is never true, or A equals A, which is always true, so I get all the data in the database. But this is blind SQL injection. In this case, this command was executed, but when it showed me the result, it only echoes back the name I put in. The developer executed this command, but they did not print out any data that came directly from the database. Instead, they echoed my input. So I know the query succeeded because I got an answer, which is different than the one that didn't succeed where I got no answer, but I cannot get any data directly from the database. All I can do is ask a question, and I get a yes or no answer. This one here, this condition is true. This condition here is false, A equals B. That condition is false. When the condition is false, I get no result. When a condition is true, I get a result. That's all I can do. So I have to figure out how to narrow things down by asking this kind of question. So I'm going to try to find the length of the database name. So I can do this. If the length of the database name is 1, then this will be true. Okay? I got no result, so this is not true. Length of database does not equal 1. So I guess that means it's greater than 1. And it is greater than 1. So I can try different numbers and find out the length of the database. And you can track down things like this. To get somebody's social security number, for example, first I can get my union here to inject a query. So now I union select 1 just to see if my ability to inject a select query is working. So that worked. So now I was able to take this select query and union it with that select query. So I can select one column and it works. Okay, so now I'll try this one. Select name from employees. This is how you can pump out a name or a password. You do it one character at a time. Okay, now I got a union select. Now I'm going to select a name from employees where name equals Bill Gates and substring name11 equals B. So this is going to be true. And what happened here is I found, I pulled the name from the employees database. The condition is name is Bill Gates and the substring of name11 equals B. So his name starts with B. His name does not start with A. If I put an A here, then it's false because the name does not start with A. So I could put something other than name here, like social security number or password, and guess what letter it is. And by the way, you can use greater than, less than with letters also. I can see if the name is greater than capital A. And B is considered greater than A. They're in alphabetical order. So this is true because it's B. So that's how you can narrow things down, and you can find the length of a name, you can find the length of a password or social security number, you can find one digit at a time, so you'll be able to extract these things with that kind of query. And that's called blind SQL injection, where it takes many queries to detect a little bit of information, and SQL Map does it automatically, which is why the pros like to use automated tools like SQL Map, but it's good for you to do it by hand a bit to learn how it works. So anyway, that's the SQL injection project, and it's working fine. And I'm going to stop this video.